You might be familiar with edge computing, you might not. You might have heard the term, might not be sure what it means, and I'm here to help you break some of that information down just a little bit. So it's kind of funny because when we talk about edge computing and we talk about cloud computing, really what we're doing is reinventing older technologies. So really all cloud computing is centralization mainframing technology. That's really all it is. And edge computing is a web. So we went, the history of the whole thing is kind of, we went from mainframes with terminals, dumb terminals, to smart devices, computers connecting to mainframes for data and processing. And then we went to personal computers, right? And then we went to the internet so that all those personal computers could connect in a web to lots of different computers. And then we went to smart devices that were able to connect to all those different computers, but they weren't powerful. So they needed some kind of centralized computational location like a mainframe. And we decided, let's call that cloud computing. And then as clouds began to get bogged down and devices began to get smarter and smarter, we said, well, let's have these devices do everything and connect to them like a web. And then that gives us, well, let's call that edge computing. And that's really all that edge computing is. So edge computing is similar to cloud computing, except for it's closer to the device. Let's take the example of networked smart cars. Really good example. So smart cars could be traveling all over the United States. They could be in rural areas. They could be in cities. They could be in urban areas. There's all kinds of places they could be. Now they need to connect to the internet. So how do they get to the internet? Well, one way that they get to the internet is daisy chain off of each other. So imagine you have a truck fleet, a smart fleet of trucks, and all of these different vehicles daisy chain off of each other until the final one is actually connected to the internet. And what they do is they transfer information back and forth. So they're getting their information from the one in front of them, which is getting the information from the one behind them, so forth and so on, until they finally, if they need information from the cloud, one of them will get the information from the cloud and then return the information all through the daisy chain. That is edge computing. In a really, really similar way, lots of IoT devices connect to the internet and get their information through edge computing. So a lot of edge devices like, say, smart light bulbs. Smart light bulbs will usually connect to a hub or a base station. Now that hub will connect to the internet. But what happens is as commands come in through the hub works directly with the light and processes information for the light. The light doesn't have a whole lot of computational ability in and of itself. It just gets commands from the hub. And if the hub needs any additional information, for example, if the hub wants to get information off of the app that you're using, then it will connect to the internet, connect to the cloud, and get all that information. Or not. The other thing that could be happening is that hub is connecting to a closer edge server. Now, if you're in the IT industry, you might be familiar with data distribution through caching. What's going on with that is, say you start with a live video stream or something like that, for example, or maybe it's a file download or something like that. So you start with that on a server in the cloud. Then that will get sent out to individual servers that are distributed throughout usually a geographical area. So you might have one server that's in the United States, one server that's in Africa, one server that's in Europe, and so forth. So the person that's in Europe tries to watch that feed. It's not going all the way out to that original machine, that original server in the cloud. What it's doing is connecting first to that server in Europe. And that server in Europe says, oh, here's the information. Now, if that server in Europe doesn't have the information, then it forwards it on to the server that's in the cloud. And that's another example of edge computing. One of the really common ways that streaming services like Netflix would use that service is a lot of people think that you're connecting directly to Netflix, but really you're connecting to some kind of an edge server somewhere that's got all of those videos and everything. All of the really popular videos, they'll put on a server that is designed for caching that data. So if it's a really popular show, they'll put it on several servers all throughout a geographical location. You'll connect to it, you'll watch it, and you'll actually be watching it from that server, not from the main cloud source. And then if you watch a show that's not quite as popular, that doesn't have as much demand, first it'll connect to the edge location, and then it'll head on up to the location in the cloud to try to get that information from there. So that's an example of edge computing. Edge computing, you can think of it as caching, but there are other examples where the data is actually processed. So you can imagine like a hospital. Hospitals deal with a lot of privacy data, and the privacy data has to stay within the network. So what can happen is if you're doing like glucose monitors or you're doing blood pressure monitors or things like that, there'll be an edge server. So your information, your personal information, will go to that server in the local network to keep everything secure and everything HIPAA compliant. So it might get all the information and make it all anonymous, and then it'll go out to a cloud server somewhere that'll do all of the data crunching on that and then send the information back, which then it can use for further calculations. So that's another use case for edge computing. So what you're dealing with edge computing is actually an awful lot of what we think of as the internet. And what really kind of confused a lot of this stuff is the use of the cloud computing, because cloud computing kind of centralized internet usage conceptually, even though it's not really, usually when you're connecting to a cloud server, it's not really a cloud server, it's a data center, usually distributed all throughout the United States. But there might be one centralized location. But you might be accessing something on the edge of that server before it gets all the way out into the internet. And that's really what you're dealing with edge computing. Another really good example, of course, is IoT with smart home devices. Many devices connect directly to Alexa through something like Bluetooth, or maybe on the local network, it connects to Alexa first. So it'll ask Alexa for some information. Alexa might do some calculation on device, might try to get some information on the device, and if it doesn't have the total solution for that information, then it might further go out onto Amazon servers, look up that information, and then supply it back to the device. And that's a really, really common use for edge computing. Edge computing is a way to design the network traffic so that it's responsive and that it gives the information that the user needs without lag and latency. And it's really the way that, for the most part, the way the internet was designed to work. Setting up networks and stuff with using edge computing is complicated. There are ways to maximize the benefits of edge computing, and if it's something that you're interested in, something that you need to maximize on your network, be sure to work with a competent IT company that can properly design and set up the network for you, like Advantage Technology. Our network engineers specialize in this type of stuff. So be sure to connect with us, and we can help you out with that.